Hello friends. So today, as I mentioned in the previous video, that today we are going to discuss about the storage classes. So basically we have total 4 storage classes in the C, and I think mostly important ones are the total three are the important ones. uh, but anyways we'll look all we'll look for all the 4 storage classes. Okay, the first one is called as an auto storage classes, and the second one is called as a register storage class, and then we have static storage class, and then extern storage class. Okay, we'll see example for each of these storage classes, and we'll see from the variable perspective, so that there can be function also which can be static, there can be function also which we can do extern, but we'll look from the variable perspective. Okay, so okay, let's start then. I will just include standard input output header file, then just main function. Okay, so let's look into the auto storage classes. So by default, any variable any C variable, when you declare without any keyword, that is an auto that comes under auto storage classes. Okay, so suppose you declared a variable as I equal to 9, declared and initialized both, then this comes under auto storage classes. Okay, so here this variable will actually occupy space in the stack of the in the stack area. Okay, occupies space in stack. Okay, and even so by default it's in automatic storage classes. uh, you can explicitly mention also, okay, it's an auto storage classes like this auto int j equal to 9, something like that. Okay, so there is nothing much in this. Only thing is it occupies space in the stack. Other thing is the validity of this storage class is within the scope of this block. Okay, so the scope of this value I and j is within this block only. Okay, so like suppose percentage d, and if I try to print I, then here it will come, and again in the next block you can again declare next block, like suppose you are writing a for loop. So for inside that for loop, again you can declare an integer type integer variable with an auto storage class. Okay, again you can declare it from 0 and less than suppose 10, then I plus plus. Here also you can basically define again. So the scope of this integer I on line number 10 is till here, and after that the scope ends. Again the scope of in this block, right, from 14 till 16, the scope of this integer I variable will be there. Okay, so if you do here printf of this integer I, then it will show the value of this internal variable. Okay, so I will try to show you. We'll try to compile and then check temp2.c. okay, then just run it. So you can see right here we have printed the value of I, and then again we have defined a new integer type as an I, and then again printed. So the scope of this variable I was till here, and after that once the new block started, again uh, this actually this variable goes away. Okay. The next question you may ask, instead of giving this for loop, can we define here as a new integer variable with the same name, int I equal to 11, and then we do printer? Will it work? Let's see. Yeah, so here also you can clearly see the scope of this I is still here, and after that again we are able to redefine the I integer, and we printed it came as an 11. But when you remove this braces, then it will give a compilation error. Okay, it's a redefinition. Previous definition is already there, you are redefining it. Okay, so auto storage class is clear. Okay, next one we'll go on the register storage class. Okay, I will delete the code for this auto storage class. So in register storage class, generally the syntax is like register int, and then we basically give that variable name. Suppose give some temp, and let's try to find key what would be the default value of this temp if we don't initialize it. Will it be 0, or will it be some garbage value? Okay, percentage d hyphen n, then temp. Okay, let's see. temp2.c. okay, so it's a garbage value, we have not initialized it. Okay, if we initialized with 9, then we'll get it as a 9. Okay, so this storage class is actually used to speed up the code execution. So we specify this storage class so that instead of storing this variable inside a memory, use CPU registers to store the value. Use CPU registers to store the value of temp. Okay, that was the purpose. But if any, it may happen that during the execution of this instruction, maybe the registers are not free, because registers are limited inside a core. Okay, inside a CPU it's limited. Okay, so if those registers are not free, means those registers are used for some other purpose to store the stack value or something, then register storage class is same as the automatic storage class, that is auto storage class. Okay, and here also the scope is also within the block of within a block. Okay, so you can again redefine temp again in a new block. Okay, okay, tell me what would be the value that will be printed here, whether it will be printed 9 or 10. So the scope of this temp, which is at line number 12, is finished at line number 13. So whenever we will print the 14th one, it will come as a 9. Okay, because this one has finished here, but the scope of this temp, which is at line number 10, is still valid till line number within this 9 to 15. Okay, so this program also will run. As you can see, you are seeing value of 9. Okay, so but if you remove this braces, it will give a compilation error. So it is same as the scope is same as the auto register, auto storage classes. Okay, so these two storage classes we have understood now. Next we'll go on the static storage classes. So in static storage classes, basically uh, the value of this static variable is maintained across the function call. Okay, and one more important thing is the static variables are by default initialized with 0. Okay, static, if I say static int as temp, and if I don't initialize it and I try to print the value of this temp, then we will see that the value will come as a 0. Okay, because this is by default initialized with 0. Okay, this one I will show you. As you can see, the value is coming as a 0. Okay, other functionality of, so here I will write default value is 0. Okay, other important things about this static variable is it maintains its value across a function call. Okay, suppose I am writing one function here which is not returning anything, just printing the value. Okay, uh, print val. Okay, I am not passing anything, just I will declare one static variable. Suppose give a name as j, and I will initialize with 9, and then I will do printf of percentage %d, and then I will do j plus plus. So whenever I will call this print val, first call will print the value of this as a 9. The next call it will not reinitialize with 9, it will again hold the previous value and do plus plus. Last value has already incremented, so next time it will print 10. Okay, so this one I will show you actually. As you can see, okay, first time it has printed 9. Again, if you call it, then it will print the next 10. It will not reinitialize. Okay, as you can see, 9 10 it has printed. This temp is for this one. Okay, so that's what is the speciality, that's what is special about the static variable. Okay, static integer type variable. We have static functions also, but that I will discuss about in a separate video. This video I will just discuss about the variables. Okay, so as you can see, if I call it again, the next time it will come as value 9 10 11. Okay, as you can see, and this variable is actually stored in the data segment. Okay, in the data segment of the memory. So I will talk about the C memory layout. There I will talk about the BSS section, data section, code section, and all. Okay, that I will talk in a separate video, but here I am just telling this will be stored in the data segment. Okay, so any static variables. Okay, so almost the third one is also done. Now we'll go on the extern. Okay, so I will remove this again, this function also I don't need. So for extern, actually we need to define a variable in some other file, and that variable I can do extern and use it in this file. So basically, using extern using extern we increase the scope of variable across files. Okay, this is what we do. Okay, so suppose some variable, suppose I create a new file. Okay, here I will just save it as a, I will just create a temp variable whose values I will set it to 10. Okay, I will save this as temp3.c. okay, then I will try to print this variable in this another file. Okay, so what I will do, I have to just do extern, then int, and then same variable name. Okay, here I will try to print the value of the extern. Okay, here just I will do temp. Okay, now we'll try to compile both the files. We need to compile both the files, then only it will find the reference. Okay, temp2.c and then again temp3.c. okay, now if you run this program, it has found the value of this variable from the other file. Okay, so basically extern is used to increase the scope of a variable across files, and this I have told about the variable. Same can be done with the functions also. Okay, so this was about the storage classes, all the storage classes in C. If you have any other doubts, you can comment in this video, then we can discuss again. I can make a separate video with examples. Mostly my purpose is to uh, tell all these different concepts through examples. Okay, thank you.